Let's discuss this particular question. It says size of an image of an object by a mirror having a focal length of 20 centimeter is observed to be reduced to 1/3 of its size. At what distance the object has been placed from the mirror? So we have to basically find the object distance. What is the nature of the image and the mirror? Now see, in the question, they have not mentioned the type of mirror. They have just given the focal length and they have told that the size of the image is reduced to 1/3 of its object size. Yes? The size of an image of an object is reduced to 1/3 of its size. That means what? Height of the image, which I am going to represent it as hi, I can say height of the image is 1/3 of the height of the object. It is reduced. Yes? Height of the image is reduced to 1/3 of its size of the object. Yes or no? Now, you know what is magnification? Height of the image by height of the object, which is also equal to minus V by U. Yes or no? For mirror, it's this one, right? Now, that means what? M is nothing but Hi by HO. You take HO to the left side, so it will become 1/3. And this is magnification, right? This is magnification, right? So magnification, we have got 1/3. Now, during the classes, I have told magnification has got magnitude as well as a sign. Now, we know the magnitude is 1/3. But what about the sign? What about the sign? See, I have already told that sign of magnification depends on the nature of the image which is formed, nature of the image. If the image is real inverted, then magnification will become negative. If the image is virtual erect, magnification will be positive. Now, since they have not given the nature of the mirror also, they have not told whether it is concave or convex, you know that if you want to get a diminished image, see, magnification is 1/3, that means less than 1, right? That means image is diminished, right? And you can look from here also. Height of the image is 1/3 only of the height of the object. So from there also we can conclude that the image, okay, the image size is less than the object size. So from there we can say that the image is reduced in size, right? The image is reduced in size, right? Or it is diminished. So when do we get a diminished image? You can get a diminished image in concave mirror as well as convex mirror. Yes or no? In concave mirror also we can get diminished image. In convex mirror also, in convex mirror you get diminished image which is virtually erect. And in concave mirror you get diminished image which is real inverted. Because in the case of a concave mirror, the virtual erect image is magnified. I repeat, in the case of a convex mirror, the virtual erect image is diminished, whereas virtual erect image in the case of a concave mirror is magnified. But in the case of a concave mirror, you can get a real inverted image which is diminished. Correct? That means you can have two cases. You can have real and inverted image which is diminished, real and inverted image which can be diminished in the case of a concave mirror. So if you take a concave mirror, you can have real inverted and diminished image, like a real inverted and diminished image. And then you can have virtual erect and diminished image as well, right? You can have virtual and erect image which is diminished, right? This can also be diminished, but the cases are different. Here, this one you'll get in case of concave only. This you'll get only in convex. Okay, only if you're very clear with the ray diagrams, you can understand all this. Okay, that means what? See, and you know that if the image is real inverted, magnification will be what? Negative. If the image is virtual erect, image will be the magnification will be positive, right? You know that, right? That means magnification can be plus 1/3 and magnification can also be minus 1/3. Both the cases are possible. So actually here we'll have two cases. Here we'll have two cases and we have to solve both the cases. Is that clear? So let's actually take this particular case where magnification is plus 1/3. And when that is possible? When it is a convex mirror which is forming a virtual and erect image which is diminished. Okay. So let's take this case. So now you have to remember we are taking which mirror? convex mirror. Now, focal length of a convex mirror is always positive, right? Because focus on the right side. So focal length will be plus 20. And plus, we don't write plus 20. You can write just 20. But if you take this particular case, this is possible only in the case of a concave mirror when it forms the real inverted and diminished image, right? So here the focal length will become minus 20. Very, very, very important. Okay. Now, moving forward. Magnification is 1 by 3, right? Plus 1 by 3. So what is magnification also equal to? Minus V by U, right? Correct or not? Magnification is equal to minus V by U, right? Yes or no? Now magnification, we know it's plus 1 by 3. Okay. So plus 1 by 3, we'll just write 1 by 3 and minus V by U. From here, you just cross multiply. So you will get U by 3 is equal to minus V. Okay. U by 3 is equal to minus V. And then you multiply throughout by minus, you'll get what? P is equal to minus U by 3. Yes or no? Yes. Same way, if you look in this particular case, magnification is minus 1 by 3. That is equal to minus V by U. Minus minus gets cancelled. From that, you'll get V is equal to U by 3. So here minus U by 3, here you're getting V is equal to U by 3. So we have two different cases. I'm solving both of them. Okay. So now, when magnification is, I was saying that when magnification is plus 1 by 3, this is a case of a convex mirror where we are getting, if you look carefully, where we are getting V is equal to minus U by 3. Where we are getting V is equal to minus U by 3. And in the second case, when magnification is equal to minus 1 by 3, I'm getting V is equal to just U by 3. Correct or not? You can look here. We are getting V is equal to just U by 3. Okay. Now, focal length is given. Here, focal length will be actually positive because it's a convex mirror. So focal length is just 20. And here focal length is what? Minus 20 because it's a concave mirror. Correct? Now, what is the mirror formula? 1 by F is equal to 1 by V plus 1 by U. 1 by F is equal to 1 by V plus 1 by U. So focal length is 20. Yes or no? Now, V is nothing but minus U by 3. See, we want to find where the object is, right? Correct or not? At what distance the object should be placed from the mirror, right? So basically what we will do now, because you need U, right? V we will replace by U because we want to find U only, right? So V I will replace by U. So minus U by 3 and plus U. Here also 1 by minus 20 is equal to, here it's just U by 3 plus 1 by U. Okay. Now you take, see 1 by something means you have to take reciprocal, right? So 3 will go to the top. So 1 by 20 is equal to 3 will go to the top. And see in the standard form, I have already told you that minus goes to the top. So first of all, what will happen? No, first of all, 3 will go to the top. And then minus will also go to the top. Actually, in standard form, we take minus to the top only. Okay. So minus 3 by U plus 1 by U. So just take the LCM as U. So we'll get minus 3 plus 1, that is 1 by 20. So 1 by 20 is equal to minus 2 by U. Now, if you cross multiply, U into 1 is U. And if you cross multiply it, minus 2 into 20 will become minus 40. And we know, right? Object distance is always negative. Yes or no? Object is always placed left side, right, of the mirror, whether it is concave or convex. So object distance is minus 40 centimeters. So you have to say that the object should be placed at a distance of 40 centimeter. This is what? Convex mirror, right? So in front of the convex mirror. Okay. See, convex mirror will be like this. Yes or no? Reflecting surface is bulging out. So you'll place it 40 centimeter from here. Clear? Next, let's solve this particular case as well. So you have write one conclusion. You have write the object should be placed because that is what they have asked, right? Let's look at this question. At what distance the object has been placed from the mirror? The object has been placed at a distance of 40 centimeters from the mirror. Clear? Let's solve this one. Here also what will happen? This will go to the top. So U by 3 plus 1 by U. So minus 1 by 20. You take, so 3 plus 1. Okay. So minus 1 by 20 is equal to 4 by u. You cross multiply. You will get what? See, first of all, minus, see, actually you can take minus to the bottom also. And then if you cross multiply easily, you can get minus 80. Otherwise, if you cross multiply, you'll get minus u is equal to 80. Then if multiply throughout by minus, you'll get u is equal to minus 80. Okay. So u is equal to minus 80 centimeter. That means here there are two situations, okay, where you can get image size which is reduced by 1/3. See, image size is reduced by 1/3, right? When the focal length is 20 and image size is reduced by 1/3, you will actually get two cases. When you take a concave mirror, you have to place the object at a distance of 80 centimeters in front of the mirror. But when you take a convex mirror, you have to place it at a distance of 40 centimeters in front of the mirror. Then now you'll get that type of image, like which is reduced to 1/3 basically. Is that clear? So here we had got two cases. Okay. So this kind of questions are generally not asked in the board exam, but yes, in the school exam, they do test sometimes. Okay. So what is the nature of the image? So see, if it is a convex mirror, you will say the nature of the image is virtual, erect, and diminished. And if it is concave mirror, because we have got both the mirrors, right? So if it is a concave mirror, it's going to be real, inverted, and diminished image, because in both the cases, it's reduced to 1/3, right? The image is reduced to 1/3, right? Okay. So you have to do both the cases and give the conclusions separately. So for this, you have to say that in this particular case, you have to say that the image is virtual, erect, and diminished. In this particular case, you have to say the image is real, inverted, and diminished. I hope it is very, very clear. Okay. So maybe I'll actually write the conclusion for you. You can say, when the mirror is a concave or is a convex one, is a convex mirror, when the mirror is a convex mirror, the object should be placed at a distance of 40 centimeter in front of the mirror. Okay. When the mirror is a convex mirror, the object should be placed at a distance of 40 centimeter in front of the convex mirror, or just the mirror, in front of the mirror. Okay. And the image is virtual, erect, and diminished. Okay. Next, same way you just write, when the mirror is a concave mirror, when the mirror is a concave mirror, the object should be placed at a distance of 80 centimeter in front of the mirror, and the image is real, inverted, and diminished. I hope it is very, very clear. Thank you.